Hello, I'm Wulf-Peter and I would like to speak about sustainability and product design. The idea of sustainable product development is to integrate environmental, social, and economic aspects from the very beginning of a product's life cycle, already in the product design stage. And this is in particular important for environmental aspects because more than 80% of all product-related environmental impacts are already determined there. That's different to social aspects. They are more determined by the way we purchase along the supply chain the different materials that we have decided to include by the product design. Economic aspects, again, are very importantly determined already in the product development phase. And what is really important from a sustainability perspective is to go way beyond the classical cost aspects. So what is the total cost of ownership? What are external costs? What are product disposal costs? That needs to be detected and influenced already from the outset. There are a lot of things that product designers have to look at. They have certain targets, they have to follow strategies, they need to follow consumer needs, they need to look at what the market is demanding, they benchmark, they lose a lot of time actually in looking around for requirements. They need to look at what capacity do they have, what are the available resources that they can have in terms of financial, but also time that they can spend in product development. They need to look at the various regulations that are governing the products that they are designing, and these depend also a little bit on the futuring. What are future regulations requiring in the different markets where we are designing for? And of course, in the center of it, from a product designer perspective, there should be the technical feasibility. But that's really not everything. They need to look at cost, budget goals. They need to see the quality, the complexity. What is the carryover content? How much of the previous design that I had potentially do I need to carry over in the new design to reduce costs? So a lot of things that impact the product designers. There are different strategies in sustainable product design, and they look at various aspects. We call them design for X because this X can be replaced by everything what you see here in the table on the right-hand side. And you can differentiate that along the life cycle stages of a product, from the early mining of all the raw materials required for the physical product, the manufacturing, the distribution, use of the product, the end of life phase, or we have design strategies covering the whole product life cycle. Let's go through them one by one. Let's start with mining and manufacturing. There's one strategy to look really what are materials that I can use for my product that have a very low impact on the environment, on social aspects, on costs. There are different approaches. There's this cradle to gate approach where you look at what are the environmental impacts related to everything from the raw material extraction until I receive that in my manufacturing stage. So from mining to manufacturing, for example, the product carbon footprint. On the right-hand side, you see an example. You can use also this web page or others where you see for different materials on a per kilogram basis what are the equivalent carbon dioxide emissions. And you can pick and choose from the technically suitable materials what has the lowest impact, and then you go forward. There's also an approach a little bit easier maybe. There's a wide list of materials that have typically lower negative environmental aspects or have from a social perspective more positive aspects. An example is targets for increasing the recycled content or the content of renewable bio-based materials. The flip side of that is a blacklist where you have everything listed what you should never use in your products. There are a lot of lists from OEMs, for example, in the automotive industry, but also in other industries, or from the regulators listing, okay, these are prohibited substances, these are toxic materials that you should never use, asbestos as an example. Yeah? Or you can broaden that to more materials and substances. But does such a thing exist? Is a material always best? Well, that depends a little bit. It depends in particular on the application and what is the life cycle we are looking at. Let's build that up step by step. We start with the mining of the ore or the crude oil, the material generation. How do I generate out of the ore the metal for iron or steel? How do I generate the plastics? Then I have different parts that I get maybe supplied from others, the housing of something that I'm producing finally, like a personal computer or car. Then there's the use phase with all its implications, and then the end of life phase, the recycling, disposal, and what have you. And in between, always the transportation that you have. And looking at this product life cycle, you always need some energy. For that, you have different sources, fossil, nuclear, renewable, depending on the region. And then you have a lot of emissions in terms of toxic emissions, CO2, nuclear emissions, noise, and so on and so on. This is the environmental side. Of course, you can have also social implications. Yeah, like is there child labor, forced labor involved? What is the positive impact? What are the health and safety aspects that you need to consider along the life cycle? And last not least, what are the cost implications along the whole product life cycle? So this is life cycle thinking, and a very good product design from a sustainability perspective is taking into consideration actually that. And if you look at that, it can be that a material A has more negative impacts than a material B. In one case, if you look at the mining to manufacturing, but then maybe material B is maybe heavier and, for example, in a car, leads to higher use phase emissions. So there might be then from an overall life cycle perspective that a material A that looked like worse because it's very energy intensive, a lightweight material, but actually has a huge advantage in the use phase, and this use phase is dominating the product life cycle overall, that this material A is in this specific application better than a material B that is easy to produce, but maybe heavier or somehow worse for the use phase later on. Therefore, there is not this inherent positive material or optimal material. Also, recycled materials or natural materials can be worse than energy-intensive materials, depending on the application. So therefore, the product designers have to look at the specific case and look into really the product lifecycle. To make that happen, you need, of course, some expertise or very simple lifecycle assessment tools. And for that, I often use in my lectures the Edemat Data app that you can have on your smartphone, where it's really relatively easy to calculate at least the carbon footprint of a product, and you can pick and choose different materials for that. Of course, every simplification has its negative impact. You can't do everything. There are certain scenarios, methodologically choices that are already made that you may not agree to, and also the eco costs that are included there. They follow some weighting ideas that you may not follow in the end. But never mind. What is important here, you find along the product life cycle from different aspects, maybe some additional hints if you design a new product. Now let's look at the next life cycle phase and design for durability in this case. The idea here is to ensure that the product design that you have is looking for more robust design so that the product can hold longer, that you don't need to exchange it so fast, and it's ideally not needed to be maintained later on. So for example, lubricated bearing bushes or robust design that avoids material fatigue. Ideally, you also support design for repairability and disassembly by making sure that it's very easy to repair and maintain. But this is the technical side. What is important on top is that the consumer is really holding on to this product as long as the technical durability allows. But to make that happen, you need to look also at the non-technical aspects. For example, the aesthetic durability is here important. You need to have a timeless design, that ensuring that the consumer isn't fed up with an outdated looking designed product, but is just holding on the product until it's not working anymore. Also, the functional durability is important so that it's possible if the technology evolves over time, that you can upgrade this product in a way that's not required to just buy another a newer product just because there's a new software or something like that. So what is important for design for durability is the technical durability of the product, plus also the functionality and the aesthetics to make sure that the consumer really is holding on, is still using this product until it's not usable anymore. But is it always better to design something that lasts forever from an environmental perspective? Now, let's look at a product like a washing machine, where you have a product A, a washing machine that lasts for 30 years. So it's a very long usage time. That's very good. You see in the darker side, okay, this is the negative impact from mining to the production. And then the lighter one, this is the negative impact, basically the electricity consumption and the water consumption and what have you of the washing machine over 30 years. And the alternative would be a product B that is, well, easier produced, not so durable, therefore maybe less environmental negative impacts in the production phase, but it lasts only 15 years. And if you add them up, the two machines that you need over the 30 years, you see it's better to have this more durable product A, the washing machine in this case. However, if you can imagine another washing machine B that is following a certain innovation pace, where you say, okay, after 15 years, now my software program is getting better. I can more efficiently wash all the clothes, and I can have less electricity consumption because of smarter technology. Maybe we have the following case that yes, you have lower environmental impacts in the production phase, and it still only lasts 15 years, but because in the second cycle your technology is so advanced, so smart, the software that you include there, that the electricity consumption is more than halved. And then in total, if you compare the 30 years, even if you consume two washing machines, you have lower environmental impacts than this more durable product A lasting for 30 years. Again, product durability is not an end in itself. It's not a target in itself. You always need to look at the whole product life cycle, considering really the longer period time, and think about that. What can we do? What makes sense most? And a colleague of mine observed that, in particular for washing machines, therefore I brought that up, made some calculations under some assumptions that you can read here on the right-hand side, and came then to a more or less optimal service lifetime for washing machines, where you have a very fast innovation pace of 6 years only. That doesn't mean washing machines should be replaced always after 6 years. That's only the case under these assumptions. And as long as in this industry there is this continued pace of innovation reducing the environmental impacts in the use phase significantly without increasing the manufacturing impacts significantly. I hope that it's understandable. Durability, great, but only if then you have not a usage-intensive product where the innovation can maybe provide more advantages if you buy a new product. Another item that you need to look at in the use phase is the consumer itself. So you need to understand the user behavior and the motivation when they use a product and understand the lifecycle implications of this usage. Then there are in this design for sustainable behavior 5 use-related design approaches how you can make sure that the user is using a product in a way that it's least damaging for the environment. For that, you need to have some persuasion strategies. One is this matching. You watch and realize how consumers really use their products and try to match this typical user behavior with a design that makes sure that in the typical design or in the typical usage pattern, the lowest environmental impact occurs. Second is you add information, for example, real-time consumption data signaling to the consumer, well, be careful, don't push further, you consume too much energy now. Or you incentivize that. You have, for example, gamification element that incentivizes the consumer to behave more rational from an environmental perspective. There might be some nudging in terms of you always go back if you restart the product. If you use that again, it's again in a default position where it has the lowest impacts. Or compulsion, force, there's only one way, and that's the sustainable way to use this product. Let's look at some examples. If we have this matching thing, top right figure A, yeah, you just try to avoid that the water is flowing all the time because somebody has forgotten to cut it off. So you have the sensor to make sure if the consumer is going close to the tap, then the water is coming. Or number B, there's information. For example, information for a driver of a car about the gas consumption. Or there's a gamification, like figure C here on the right-hand side. You always say, okay, now you have an environmental driving behavior, and therefore you get more points or something like that. And you have here the figure E that is more or less forcing you. You can only use this tap water the following way, and that's using cold water rather than hot water. So these are examples for design for sustainable behavior with the different persuasion strategies. Now let's turn to the design for dismantling, and there's an interesting video that I can recommend here also. You can have the QR code there. Design for dismantling is always about an easier accessibility of all the connecting elements, the clip screws and so on and so on. It's easier to access them. They are standardized so that you don't need different tools. You reduce the number of connectors, and it's easier to detach them. Number 2, you have a modular design. So you can you can take out a certain part of the complex product and upgrade it with the newer equipment. And of course, all of that works only if you have a logistics for returning the products back. Otherwise, it makes no sense. The design for recycling is a little bit similar. It's based on design for disassembly rules, plus adding the idea to always have materials together in a part or in a product that you can recycle together. The third item there is that you use recycled content. So that's design for recycling as an extension of design for dismantling. We can have different examples. On the left-hand side, you see, for example, Fairphone, a smartphone that is easy to detach. And then you have here an electric toothbrush. Here's a video how long it takes to actually dismantle this toothbrush to just get to the battery here and replace that one. So that's a bad example, and this is a good example. Take a look at the videos. Now, there's also in this design for X, the end of life focus, and there are these R10 rules, and that's what you see here. From reuse, rethink, reduce, reuse, repair, refurbish, remanufacture, repurpose, recycle, recover, regenerate, and we have now N1 and N2, that's natural things, where you have regenerative biological materials or this biomimicry option. So these are end-of-life typical design standards, and let's go through them also. If we look from R0 to R2, this is all about the smarter product use and manufacture. So what you can see here is the idea to make sure that you reduce the needed products. And one idea or one product here is the smartphone or the ebook, that you can replace several products by one, or a whole library by just the ebook. So that's an idea to reduce and consume in the end less physical materials. That's one idea of this R2. If we look at the next principle is slow down the material flow. Make sure that there's not a fast one-way consumption of materials, but let's keep them longer in the technosphere. So one example is this repurpose. You can have these old containers and build new houses out of that. And you see here other examples or description in the descriptions here. Then there's another principle, useful applications of materials, where you think about how can I best recycle something and take it back to a new product. And this is this example that you see here, a bumper-to-bumper recycling from an old car bumper to a new bumper. So that's, of course, one of the examples that you can follow. And then nature-inspired design can be something like this materials made out of mushroom, that you have in the end 100% biodegradable material, or some honeycomb lightweight construction, composite material, where you have really very light material, but that is very stiff and very strong in the end due to this honeycomb lightweight construction. Nature inspired. So there are a lot of obstacles, of course, that you face if you have this end of life perspective also in your product design. One is this lack of compatibility with the new product. So if I want to reuse something and recycle that, there might be not a compatibility with the new software or whatever. Software levels or new infrastructure are required. And you always have then this issue that you have new products that always compete with their refurbished or remanufactured old product, and the new products have just more functionality because that was never foreseen before when designing the old product before. Very important, however, is the return logistics. How to get all these products, the old wasted products, back to you and refurbish them, remanufacture them, recycle them in another way to keep the circular economy going. That might be very burdensome, very costly, and also environmentally not very positive. What you can, of course, impact in the design phase is that you ensure that the repair costs are low. And you can make sure that, to a certain extent, the technology changes that will happen in future can be maybe incorporated by an easy upgradable modular design. Last not least, very important, and we had that already a little bit with this timeless design aesthetics, you always need to make sure that there's consumer or customer acceptance for recycling. Very important, and that's also a question of the image of end-of-life products. So in the end, you need a cooperation between all the different stakeholders and think beyond your product that you design. You need to integrate what we have seen also in the beginning, not only the requirements of all the lifecycle stakeholders, but you need to actually involve them and make sure that you work together for the end-of-life logistics, for example. Yeah? So what do you need is to think beyond the product, and you must ensure. So very important, you need to complement your product-focused design with a system thinking. So for end-of-life focused sustainable design, of course, you need to continue to think about having as few as possible connecting elements, as easy as possible detachable and standardized ones. It needs to be accessible for all these tools. You need to think about recycling compatible materials, modular, durable design, but you need to add there thinking in systems. How can I set up a return logistics, a deposit system, an incentive for the consumer to bring things back? What is about the supply chain, the value chain, the lifecycle management? Actively organize all the different stakeholders and get acceptance by them. And then what are new business models maybe? What after-sales service models do you have there? How can I establish a sharing platform to ensure that there can be later on refurbishment or R10 philosophies implemented? And looking at the business models, think about sharing, leasing, product as a service, and other opportunities to go beyond the product in itself. So further methods for sustainable product design include checklists, multi-criteria requirement matrices, lightweighting, environmental failure mode, effect analysis, design for sustainable systems, product sustainability index, and. So there are a lot of other methods that you can use. But what is important is to always think twice, remain critical, remain self-critical. Is really, it's so easy that material A is always better, that a durable design is always better, that recycled material is always better. Think always along the life cycle. What appears sustainable at the first glance may not be so convincing on a second one from a more holistic perspective. Always think about possible trade-offs, not only from an environmental perspective, but also a social and economic one. Sustainable design clearly needs to go beyond the product itself. It needs to think about new product service systems, new business models, lifecycle stakeholder involvement, and always think about there's nothing for free. There's nothing without any negative effects, but you need to have a product. That's your job as a product designer, and the perfect is the enemy of the good. So look at what is really the best amongst the realistic solutions. More on that you can find in chapter 4 of my book, Solutions for Sustainability Challenges. And with that, I would like to thank you for your attention and wish you all the best. Thanks.